The paper we're diving into today is Project Iceberg, the Iceberg Index, measuring workforce exposure in the AI economy.
And that title, it really gets right to the point. The core finding is that AI is fundamentally restructuring the U.S. labor market. We're talking $9.4 trillion. And our old ways of measuring things, they just can't keep up.
Okay, so that's the setup. Let's do the 1-minute summary right at the top. This paper, Project Iceberg, it uses what they call large population models, or LPMs.
Right. And these aren't small models. They simulate 151 million workers, 32,000 skills, and how they interact with, over 13,000 real-world AI tools.
And the main output from all of this is the Iceberg Index. It's a metric that's all about skills. It measures the wage value of skills that AI can technically do within a job.
It's about technical exposure. And here's the kicker, the part we all see, the surface index in tech jobs, that's just 2.2% of wage value. About $211 billion. It's the tip of the iceberg.
Literally the tip. Because the hidden part, what they call cognitive automation in roles like admin, finance, professional services, that's 5 times bigger.
5 times. We're talking 11.7% of the total wage value. That's around $1.2 trillion.
And critically, that trillion-dollar risk isn't just in California or New York. It's spread across every single state, which completely changes the conversation. This whole index is designed to give leaders a heads up before the disruption really hits.
Oh.
So let's start there. Why are our traditional metrics failing us? We've always relied on GDP, unemployment numbers, census data. Why are they suddenly not good enough?
It's because they're all lagging indicators. That's the key thing to understand. They measure what happened after the fact, after the jobs are lost, after the new companies are created.
So you're always reacting, never anticipating.
Exactly. By the time unemployment numbers tick up, the structural shift has already been happening for, maybe years.
The paper has a great phrase for this. They call it the Census blind spot.
They do. And it's because so much of this new work, these human AI teams, it's not happening in a physical office that a census taker can count. It's happening on digital platforms, in workflows that are basically invisible to government data collection.
The job categories themselves are becoming outdated.
They are. That's why you need a measure that looks at the underlying skills, the capabilities, before the job title even changes.
Which brings us right to the definition of the Iceberg Index. The paper is very clear. It's a map of technical exposure, not a prediction of job loss. How important is that distinction?
Oh, it's the most important distinction in the whole paper. It's a capability map. Think of it like a seismic risk map for earthquakes.
Okay.
It shows you where the fault lines are, where the pressure is building up. It doesn't tell you when the earthquake is going to happen. That depends on other things, business decisions, regulations, investment. This is just the structural risk.
That makes sense. But we do have other AI benchmarks, right? Like GDP Val or Apex. They test how well models perform on professional tasks. Why not just use those?
That's a great question, and it's a key technical point. Those benchmarks test a frontier model, the base AI, on a theoretical task.
In a lab, basically.
In a lab. The Iceberg Index is different. It measures systemic exposure from the entire ecosystem of over 13,000 deployed production tools. The Go-pilots people are using right now, the automation software already in accounting departments.
So it's about reality versus potential, what's already out there in the wild.
Precisely. It's a difference between a new engine on a test bench and the performance of all the cars already on the road.
Let's quantify that tip of the iceberg then, the surface index. This is the stuff we read about, right? The tech layoffs.
Correct. That visible part is 2.2% of national wage value. It's concentrated in states like Washington, which is at 4.2%, Virginia at 3.6%, and California at 3.0%. These are the known hotspots.
Now, I was really impressed by the validation. They checked their model against real-world career changes. It says they achieved 85% recall. What does that mean in simple terms?
It means their digital map of skills actually matches how people move around in the real-world job market. They looked at data on who switched from what job to another, and their model could predict those transitions with very high accuracy based on skill similarity.
So it proves their skill taxonomy isn't just theoretical. It reflects the real structure of the labor market.
It does. And then there's a second validation. They compared their surface index predictions to the Anthropic Economic Index, which tracks actual AI usage.
And how did it do?
It showed a 69% geographic agreement. This is huge. It confirms the Iceberg Index is a genuine leading indicator. It successfully identifies where the structural exposure is building up before adoption becomes totally widespread.
Let's shift gears and go under the hood a bit. For our audience, the mechanics here are pretty fascinating. The whole thing is built on MIT's large population models and runs on the Frontier supercomputer. Why do you need that kind of firepower?
Well, because this is simulation science, not just statistics. You're not just looking at past data. You're building a synthetic digital twin of the entire U.S. economy.
151 million workers.
151 million workers, each with 150,000 attributes. You're simulating billions of interactions. You need a supercomputer to model the ripple effects of, say, one policy change in one state on the entire system over years. You just can't do that with standard regression.
So that brings us to their three-step process. Step one is mapping the human workforce. It sounds like creating 151 million avatars.
That's a pretty good way to think about it. It's an agent-based model. They know each worker's skills, education, location, income, which means they can model not just the job someone has, but what other jobs they're qualified for.
And then step two is the key, right? The AI workforce mapping. They map AI tools using the same 32,000 skills.
Right, the Rosetta Stone. You have to speak the same language. They took thousands of production AI tools and broke down what they can do using the identical human skill taxonomy. That's how you get the overlap score.
And this lets them see the difference between AI augmenting a job versus transforming it.
Absolutely. The paper gives a great example. If an AI automates a nurse's paperwork, that's augmentation. It frees them up for more patient care. But if an AI automates most of a software engineer's coding tasks, that's transformation. The job itself fundamentally changes to one of oversight and architecture. The model can see both.
And the final step is the simulation itself, where they bring it all together.
Yes, that's the sandbox. It's where they can test policies. What if we invest in a huge reskilling program for Skill X? What if we offer tax incentives for small businesses to adopt AI? The simulation shows you the likely outcomes, both the direct effects and the unexpected indirect ones, before you commit real resources.
Okay, moment of truth. Let's talk about that hidden mass. The surface index is 2.2%. What is the full 11.7% Iceberg Index really telling us?
It's telling us that the conversation we're having in public is missing about 80% of the picture. That $1.2 trillion. I mean, that's roughly the entire GDP of Australia. This isn't a niche issue in the tech sector. It is a systemic, economy-wide exposure.
And it's almost all cognitive automation. We're not talking about robots on an assembly line here.
Not yet. We're talking about white-collar, office-based tasks. Document processing, scheduling, financial analysis, HR functions. The paper even cites IBM reducing HR staff because of AI. This is the support structure, the administrative backbone of every single industry.
Which explains the geography. Unlike the tech-heavy surface index, this exposure is everywhere.
It's everywhere. The map of risk just gets completely redrawn. You see states like South Dakota, North Carolina, Utah. Their Iceberg Index values are actually higher than California's.
Why?
Because they have huge concentrations of back office, administrative, and financial service centers. Their visible tech sector might be small, but their hidden cognitive automation exposure is massive.
So this leads to what the paper calls the automation surprise. Where's the blind spot biggest?
The industrial heartland. The Rust Belt states. Think Ohio, Michigan, Tennessee. Their leaders are, understandably focused on the future of manufacturing and physical robots. They look at their low surface index for tech and probably feel pretty safe.
But the real risk is already there, in the offices supporting those factories.
Exactly. The logistics, the accounting, the supply chain management, all that cognitive work is being exposed to automation right now.
And the numbers for a state like Tennessee are pretty stark.
They're shocking. Tennessee has a surface index of only 1.3%, but its full Iceberg Index is 11.6%.
Wow.
Their hidden risk is nearly 10 times their visible risk. If you're a policymaker only watching for robots, you're completely missing the tidal wave that's already on its way.
So understanding the scale is one thing, but the paper actually offers a framework for how to respond. It uses something called the Herfindahl-Hirschman Index, or HHI. What is that measuring?
HHI is a classic measure of market concentration, but they've cleverly applied it to risk. It basically tells you if that 11.7% exposure in your state is concentrated in just one or two industries, or if it's spread out all over the place.
And why does that matter?
Because your strategy has to match the structure of the risk.
Okay, so let's take the two extremes. A state with concentrated risk, a high HHI.
Right. Think of a state in the Northeast Corridor, maybe Virginia. Their risk is probably clustered in finance, insurance, and tech. So the solution can be very targeted. You can create specific reskilling programs for finance professionals, for example.
And the other side, a state with distributed risk, a low HHI.
That's your Iowa or Ohio. The exposure is spread thinly across manufacturing support, logistics, healthcare admin, local government. You can't just fix one sector. You need a broad, system-wide response. Things like updating the core curriculum in all schools to focus on data literacy.
This really drives home how much the traditional metrics are failing. How weak is the correlation between the Iceberg Index and something like GDP?
It's basically non-existent. It's shockingly weak. Now, the traditional metrics, GDP, income, they correlate okay with the surface index. Wealthy states have big tech sectors. Makes sense.
But not with the whole iceberg.
Not at all. GDP, income, and unemployment explain less than 5% of the variation in the full systemic iceberg index.
Less than 5%. So a state's current economic health tells you almost nothing about its future AI risk.
Nothing, because every state, rich or poor, has administrative and professional support jobs. And that's where the hidden risk is. Relying on unemployment numbers to track AI risk is like, trying to find a gas leak with a thermometer. You're using the wrong tool entirely.
So what are the three big strategic functions this index gives to leaders?
Okay, first is just status quo assessment, knowing where you stand, identifying the risks of doing nothing. Second, and this is important, is strategic opportunity identification.
So it's not all doom and gloom?
No. Automating hospital paperwork doesn't have to lead to layoffs. It could free up nurses to spend more time with patients, which actually helps solve a labor shortage. It's about turning automation into augmentation.
And the third?
Recalibrating investments. For decades, we've used these job multiplier assumptions. Build one factory job and you create 1.8 support jobs. Well, if AI is about to automate those 1.8 support jobs, the return on your investment just plummeted. You have to rethink how you spend public money.
This paper, Project Iceberg, it really feels like it provides the essential foresight we've been missing. It shows that AI's real impact is 5 times larger than we thought, and it's happening everywhere in these cognitive roles.
It's the capability map. It allows leaders to finally move from being reactive to being strategic and prepared for what's coming.
And as we wrap up, it's worth remembering that this entire model was validated using data from a human-only labor market, how people switched jobs in the past.
Right. But the whole paper points to human AI teams as this huge blind spot. So that brings up a final thought, a question for you, the listener.
Go on.
As humans and AI start working together more closely, co-evolving, it's not just about tasks being displaced anymore. It changes how all the other tasks are done. So how does that force us to rethink the very idea of skill similarity? The connections between jobs might be fundamentally changing, which means the next generation of these models might have to be completely rebuilt from the ground up. The nature of work could be changing faster than we can even model it.